We're at gotomath.com. We're working some calculus. We're in the related rates section, and I believe that's the button that we're doing. Air's being pumped into a balloon. Yeah, that's it right there. Okay. But we're going to actually use this guy here, but I'm going to there, change the numbers. Okay, we have the answer down there. We don't want to cheat. All right. Let me let's see. Let's read this. Air is being pumped into a balloon at a rate of 22 cubic feet per second. So that's dV over dt. I got to write these numbers down. 22. Find the rate of change of the radius. We're looking for dr over dt when the radius is 2.7 feet. Round your answer to 2 decimal places. Okay. So we have a sphere. Actually, we had a balloon. We've already done the sphere problem. We got being pumped into a balloon. All right. We're going to pretend that this balloon is a perfect a spherical object. All right. And of course, my diagram's definitely not that. All right. And this is obviously R here. But this is supposed to be a perfect spherical. That's not it. We're going to use the formula for finding the volume of a sphere, and we're going to consider our balloon to be a perfect sphere, which I know that's not impossible, but this is just a model. Okay, some things that they gave us that air was being pumped into the balloon, so that's going to be volume, dV over dt, and that's going to be I think it was 22 cubic feet per second, I believe, and R was equal to 2.7 feet. All right, 2.7 feet. That's the radius of this balloon. I want to make sure 22 cubic feet, 22 cubic feet per minute, 2.7. Make sure all my numbers are right there. Okay, so what we're going to do is take the derivative of this guy. And with respect to t, the derivative of v is 1, but then we're going to write dv over dt, and then bring the 3 out front. 4/3 pi r squared, and then dr over dt. Alright, now they gave us dv over dt, which is 22. We'll write that right there. We can cancel those 3's out, clean this up a little bit. R is 2.7 squared, and then dr over dt is what we want to solve for, right? We're trying to find dr over dt. We want to know what's the rate at which the radius is increasing. And so all we have to do is, this is pretty simple here. 22 over, bring this diagonally down, 4 pi, and then 2.7 squared, and that's going to be our dr over dt. Our dr is morphing into a dv. Now it said approximate to 2 decimal places, so we'll want to do that, and I'm going to cheat and plug that into a calculator. If you consider that to be cheating, 4 times, let's see, 4 pi times 2.7 squared. Okay, let's see what I get. And I get, let's start with a 0 here, 0.24, and then it says 0.15, but we can just stop right there. Okay, so dr over dt is 0.24. Now remember, we don't want to leave off our units. This is feet per second, okay, feet per second, 0.24 feet per second. So let's come over here, hold my breath, and it looks like the anyway, we both agree, so that should be it. All right, So remember, we are in this section here, and we're doing related rate problems. This is the actual web page here, of course. And remember where you are. You're at gotomath.com. And I'll see you there. Bye.